Is it recording already? Mm-hmm. So up until this point in our PiPlantMonitor project, the entire thing has been PiLocal, which is to say that our web application, our sensor reading, our database interaction has all been contained on the Raspberry Pi itself, which is all good and well for our system, which is just to keep our bonsai alive. But it would not be feasible if you had a larger crop that was, for instance, outdoors or in a greenhouse, let's say. By the way, if you're just joining us now, where the hell have you been all this time? And look over here for a playlist that takes the entire project from the first iteration up until where we are right now. So a larger scale of functionality can be achieved if we were to move our web application over to a separate device that can be powered on and connected to a network at all times. So a web server would obviously be ideal if we were going large scale, but my laptop will suffice as the web server in this instance. So if we run the web application on a device that is separate from the Raspberry Pi itself, this frees up the Pi to only run whenever it needs to take a reading. So this is why I've had the PiJuice hat connected to the Pi from the start of the project. Some of the introductory videos is that the PiJuice hat enables us to perhaps power the Raspberry Pi with a solar panel, for instance, and it also contains the functionality that makes it possible for you to program it to power up only once a day or twice a day, for instance, to take its readings and power back down. But now that does raise the question of how do we get these readings across from the Raspberry Pi onto the web server? In other words, onto the device that's running the web application that's actually exposing our database tables of readings to the users of that interface. Enter REST APIs. If we add an API endpoint to our web application, that means that the Raspberry Pi will be able to take its latest reading and push that across in an HTTP request by communicating with our API endpoint. Our endpoint then adds this data to a corresponding database table to be exposed to the same CRUD, create, read, update, delete interface that we created with the Flask web application in the previous installments. Yeah, that's it.
Okay, pay no mind to the clinky sounds in the background. It's kitty dinner time, and we got them metal bowls for their food as well as metal pendants that hang around their necks, so they clickety clink 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 while they eat. But you know, it's less than the amount of noise they make when they're trying to convince you that it is dinner time. That part is a little bit incessant. So while they eat, we can work. Now, since we're moving across our web application from the Raspberry Pi to my Windows laptop, we need to take all of the same dependencies and install them into a new virtual environment. So I've taken the liberty of creating a folder already and adding our web application, which is our Flask admin web app we built the last time, and adding that into the folder. So now I'm going to make use of Venv to create a new virtual environment, and then inside of that virtual environment we're going to install all of the same dependencies that we worked on previously. No idea where that was typing now, so that's somewhere for us to find later, and we're going to choose this folder that we are in right here. Tab it. Oh, look at. So now we have our Venv created, and now we want to go ahead and activate that. Again, where am I typing? Oh, it's like that, is it? I see. Activate my damn thingamabobajiggy. Trust this command. Okay, yes, sir. As admin, why not? Yes, thanks so much. Okay. Scripts and activate. Yes, we've created it. Marvi. Oh no, we're going to activate it, is it? PowerShell. Did you look at that? Polax in step 1. Activating health. Why is it so hard? All signed. So, let's change our execution policy. Yes to all. And now, /activate. Fixed it. Always run this cack. Boom. So after 25 years and ample graying of the temples, we now have our virtual environment actually activated. Now we can install things. that we need. So, if you recall, what we were using is some Flask SQL Alchemy, and some Flask admin up until this point. So let's install all three of those. pip3 install Flask capital F, if I remember correctly, capital A. Okay, so this will install and give us a virtual environment that pretty much looks the same as what we had on the Pi. So everything up until this point was literally just getting that to work. But here we are. Let's see. We've got Flask admin, markup safe, SQL Alchemy, werkzeug, Flask SQL Alchemy, it's dangerous, and what the forms. Cool. So now comes the action. What we want to do, having moved the Flask web application across to this new machine, is we want the web application to now be able to receive its information from the sensor reading application on the Pi, which is no longer running on the same machine, no longer saving to the same database by default. So the way we're going to do that is we're going to have the web application accept HTTP requests from the Pi. And in order to do that, we need to implement an API endpoint for each one of our database tables. Flask provides plenty of functionality for building APIs through both RESTful and the RESTless extensions. But if we were to look at FlaskRestless in particular, FlaskRestless is perfect for our needs because it generates RESTful APIs specifically for database models that were defined using Flask SQL Alchemy. That's us. How does it know? Huh? We did that. So because we did that, FlaskRestless is exactly what we need. Okay? Like it was written just for us, especially. So we need to add the API generation code to our web application, and then we need to alter the function in our sensor reading app on the Pi to send reading data to the endpoint in an HTTP request in JSON format. So today we're going to start with just the API endpoint bit. Let's start by creating that. So nice thing about Restless also is that it's one of the extensions in standard Flask, so it's not another library that I need to install. I just need to import it from flask.ext.restless. We import what's called the API Manager. I'm seeing now that this version of the app that I've copied across did not yet have that all-important secret key. So I'm just going to add that back in, lest we run into those problems again and not understand where they're coming from. It's a secret, okay? Right. So we've initialized our database as well as our admin interface. Now we're going to initialize in a very similar manner. This seems to be the way that all of these Flask libraries work with these classes and objects, which makes it really easy to remember the overall flow of how this goes. We're going to initialize something called, or we're going to define something called manager, and that's going to be an instance of API manager. In other words, it's going to be an object of the class API manager. We pass in the arguments app having been defined up there, and we also tell it what the Flask SQL Alchemy database is, and that is what we've called a DB. So now our API manager already knows the application context in which it's working, and it already knows what the database file is that it's going to expose over these API endpoints. In a sense, not really exposing the database, but providing an interface for HTTP requests, the data coming across HTTP requests to be added to that specific database table. We have our classes created for sensor and reading already, and we have each view page for each one of those admin views that we created in the previous installment. So now we're just going to add an API endpoint for each. So underneath our views, we're going to make use of manager and go manager.create_API sensor, pass in the class that this API page is going to be related to, and we pass in which methods it accepts. In our case, we only need post, because we only want to be able to receive data from the Raspberry Pi. The Raspberry Pi is not going to be performing any actions that requires it to receive data from the API. So if we wanted to add functionality such as that, we'd add get, in which case the Raspberry Pi could send an HTTP request, a get type HTTP request, and then receive a certain amount of data from the endpoint. But in this case, the Raspberry Pi is only pushing data to the endpoint. So these API endpoints are going to be completely deaf to any kind of request that is not a post request. The other request types, of course, being essentially CRUD. It's post, put, get, and delete. So post is to create, put is to update, to read information would be get, analogous, and delete is delete. Create underscore API, reading. Again, our methods being simply post. And that is literally that. This is the easy bit as far as the coding goes. FlaskRestless has really made it possible there for us to create 2 API endpoints using 2 lines of code once we've actually initialized or defined our manager as being part of the app. It already knows what database it's working with, being, did I copy that across yet? I'll need to, otherwise it'll probably create it anew for me here. The declarative base class for normal SQL Alchemy is something that's sort of implied already in Flask SQL Alchemy. It's something that already exists, and scoped sessions exist already as well. I believe that it's actually going to go ahead and create that database for us if it doesn't exist yet the first time that we run it. So we have our API endpoints. We would need to update the sensor reading application, but a useful way of developing this, or the most, let's say, robust way of developing this would be to test the API endpoint before running the application that's going to interact with that API, or before building the application that's going to act with that API. So it's a better idea to test that this endpoint is actually something that works right now. So for API testing, I like to use Postman. It's something that has a really nice intuitive sort of user interface and flow to it. You can literally just double click and create requests as needs be. So once we have our Flask app running, let's see if we can go ahead and create a request and then send that request along and see if our API will be listening. Remembering we used export on the Linux system on Raspberry Pi, but here we say set flask underscore app, same folder, equal to hi flask.py. Yes sir, it's done. And now Python -m flask run. Don't lie to me, bro. You mean no module named Flask? You just, of course there's a module named Flask. How dare you? That's insulting. Flask has been installed inside of our PiPlantMonitor venv. Fine, let's try it here. Shall we set, where's my autocomplete, huh? Windows, why you gotta be like that? Why you gotta treat me this way? Python -m flask run. Could not locate. Is that so? It says, oh, that's because we're in the scripts folder. This is my fault. Let us try it again. Set it. It's my fault. I was in the wrong folder. Should work now. How dare you? So if PiPlantMonitor hi Flask, that's literally where we are. Absurd, bro. Completely absurd. I mean, we're in the folder. Virtual environment is active. I've set the Flask app environment variable. One tires of this. One tires of it rather quickly. Oh, because I'm in PowerShell and not command prompt G. Equals and with thingy signs, I mean flask.py. So again, my fault, as it always is. 100% of these kinds of issues is user error, because the computer's always right. So, using the correct PowerShell syntax this time, I've actually set the Flask underscore app environment variable to be hi flask.py, and now if we Python -m flask run, we see other issues. Cool. From Flask import Flask CD. What? You see, this is where this accidental type has gotten. Look at that. I knew it. I was typing where I thought it was the terminal, but I wasn't. I was typing over here. I was adding things invariably to my actual app, which I obviously did not want added. It looks like that's the only instance of that occurring. Now let's try this one more time. Environment set, Python Flask run. What else? Was I lying to you? Do you actually have to install Flask-Restless? Flask-Restless, is that a thing? My good, Flask-Restless is a thing. I'm a total liar. I lied to you, to your faces on the internet without my face. I lied to you, okay? So, Flask-Restless needed to be installed. What this time? I mean, from Flask_Restless, import the API manager. How's that? One more time. We made it. So, this is running. Let's try our one. Bought 5,000. So of course we don't have all of that home page text because I haven't copied that across with the templates folder. So I'll go ahead and do that at some point. And we're having issues, which we thought we would. What's crack-a-lackin'? No such table. Does it not yet exist? Is that the problem? Operational error. Operational error. Okay. So look, this is all to be expected. I'm going to go ahead and copy across the working database. That guy. Pew. Pastiche it in here. Delete this one. And rename this to just be our database. Let's see. Let's try that again. Set our environment variable. Runneth. Refresh. Boom. Okay, and reading should work as well. Marvelous. Okay, so now that our application is running again, what we want to do is Flask-Restless does require installation, so joke's on me. So host port, there we go, /API /that. So let us try and create a request. /API /reading. We're going to post something. We should probably include some kind of data. Now, what is our application expecting to receive? As far as reading goes, it's expecting to see a date, a description, and a value. Give it just that. You want to tell it that you're giving it JSON data. No. You want to tell it that you give it JSON data, because that's all our API is going to be able to interpret. Isn't it always? And let's give it a respectable date. Why is this a bad string? Unable to decode data. So, fact of the matter is we receive a 400 bad request, which is a start. That means that this endpoint, localhost /API /reading, actually exists. Isn't that great? So all we need to do is correctly format the body. And I seem to be drawing a little bit of a blank as to what that would look like. We'll find that, and this will all be edited out in the final, of course, because don't want to appear unprofessional. That sort of look. We want that sort of look, don't we, son? That sort of look. Marvy. Description. And that description is going to be, and we give it a value. And that value will be off the charts. 800. Happy with that? Let's try that again. Booyah. Chakalaka. My friend, it has assigned ID number 7 with a value of 800, and that information that we've just applied there to our reading table. So now, if we go across to our readings and refresh, there she is. And just shifty this across. That's better. That's been added to our database table. The same can happen with our sensor table as well. And our sensor table expects date, name, and pin. So, date, same date, name, another test request data. There we go, date, right? Name, test request data, and pin 25. Why not? 500. Since the Raspberry Pi doesn't have that many pins, we'll know that this one was a toke. And we add that to the sensor endpoint. We receive the same data that we sent in a response, but it also gives us the ID in response. That ID is auto-assigned because we have that primary key that auto-increments for our database table. So the sensor table had 2 entries, I should say, and it just gave the ID of 3 to this new supposed sensor that we just sent across with data. So again, if we go into the browser, we refresh our sensor page, there's our test request data. So now we know that our application's API endpoints are listening for these posts, and it successfully receives the data in HTTP requests as long as it is JSON formatted. So all we have left to do, well, I say all as if it's going to be a little 5-minute. It's going to be a bit of a daunting task, if I recall from the first time I did it. But all we need to do is have our sensor reading application now updated so that it pushes the actual reading and actual sensor data, especially the reading data. Actually forget the sensor data. It's not going to send new sensor data. We're not going to code that functionality just yet, but it would be similar to the reading data. But so let's just talk about the reading data and pretend that I didn't mention the sensor data at all. It's going to push the readings that it gathers from the sensors across in the same JSON format. After it's added it to DB models, it has to convert or serialize that data into JSON format and then push it across in an HTTP request. We'll also be running this on the public IP of the laptop next time round so that the Raspberry Pi can actually reach it. Right now we're running on total home localhost situation, which is obviously not visible to any other devices. But there you have it. We have 2 working API endpoints ready to receive data from our Raspberry Pi. To join us for the next installment, but until then, keep learning things the hard way. All right.